Hello everybody and welcome back. In this video solution, let's dive into the problem find all duplicates in an array. I think what makes this problem a medium one instead of an easy one is the constraint of order of 1 space. Let's jump into it. I want to start off with the general discussion of the problem because there is one constraint over here that is going to make our life so much simpler later on. So we'll want to talk about that. The first thing, we're given the inputs, which is a list of integers, nums, and each of these nums is in the range of 1 to n. Okay, this is the condition, by the way, that becomes important later on. We're also given the fact that each integer appears once or twice and could either appear once or twice. And you have to return all of those elements that appear twice. So the output in this case is 2, 3. Since 3 appears here and here, 2 appears here and here. Rest of the elements 4, 7, 8 and 1 appear only once. Once we come to the solutions, I actually want to know what you guys came up with before looking at this solution, and let me know that down in the comment section below. Let's talk about the logic of the problem. The first thing we want to note is frequencies. We want to be able to know that X occurs once in the entire array, Z occurs once and A occurs twice. And once we are able to get this information, we can collect all of those elements having this frequency of 2. And once we have collected those, we can return them at the end. But the thing is, this frequency itself will take order of n space to store, since we want to know that for each and every single element. An order of n space is something we can't have. So what we want to do perhaps is an in-place operation. What we want to do is we want to somehow store this information of frequency along with this original element inside of the element Z. So Z will now contain the information of Y as well as the frequency. We'll talk about how we can do that later, but there is another couple of things we want to look at. First is the fact that this array has, like an array, not only has some elements, but also has indices. So in fact, we're not just dealing with a list of elements arranged in any order, but we're dealing with a list of elements that are indexed. What is the element present at the index I? You can return the answer as X. What is the element present at the index L? You can return me B. So on and so forth. So perhaps we can combine both of these pieces of information to get close to our answer. In fact, there's one more thing I want you to look at. The indices are given in the range of 0 to n-1. N here represents the number of elements in this list, and so n-1 represents the last index. Indices are given in the range of 0 to n-1. Nums is in the range of 1 to n. Look at the slide before we had. Let me show you. Nums, each of these nums are given in the range of 1 to n. Now, I will ask you, do they not look oddly close to each other? Like it's just shifted by 1 and we'll get the same range again. There's something interesting going on in here and we'll want to come back to that later on. There's one last thing where we want to talk about here, which is communication. See, if we have two of these x's in the array, they should be able to communicate with each other saying that, okay, I am at the frequency 1 and now once we look at this guy, we can say that our frequency is 2. Somehow we want to have both of them communicate with each other. Let's write all of these three things down. First, we want to store all of those frequencies in place. So store all of the information of the element as well as the ID of frequency in place. Then we want to exploit the properties of these indices, which look oddly close to the ranges. And third, we want to have them communicate with each other. Now the next slide I'm going to show you contains the entire logic for this problem. It is a bit dense, so let's get started. Okay. Let's say that you are looking at the index I. At this index I is present the element X. You want to know and you want to mark the frequency of this element and increase it by 1. Let's say that you haven't encountered X up till now, but this is the first X you are encountering. So how can you somehow store this frequency of X? The thing is, we are at this index I pointing to the element X. Since we know the indices and these ranges are very close to each other, we can just do x minus 1 which we'll know then definitely is an index. And this index can now point to this particular value y. Now this y isn't exactly important, but we can have this index store the information that this x has been visited. And what we'll do is we'll convert this y to a negative y. The thing we talked about before was this in-place storage of these frequencies and these ideas. What we're essentially doing is we're saying minus here means that this particular index has been visited. So the x value has been visited. This minus thing tells us that. And the y remains as is. Y tells us what the original value here was. So in this way, we are not only storing the information of which all have been visited, but what their original values were. So we're not disturbing the original thing and we're adding more information on top of that. Now this is interesting in and itself, and you'll also note that we are sort of communicating here that, X is storing this information over here, but it's going to get more interesting in the next slide. If you look at this case, we have let's say that we encountered this X and we set this Y to minus Y. This minus definitely means that this X value has been visited. And so let's assume that we iterate on and we encounter this X and J again. So this is some other index J and it has the same value X. Now this X can communicate with this X via this particular index over here. And what we can do is we can say that, hey, this minus Y can get converted to Y, since we said that, we want to flip this around always. We want to put a minus there. So originally it was minus Y, and then we encountered this X and we made it to Y again. If you notice, all of the X that have been visited twice will have this value Y, start from Y, go to negative Y, and then go to positive Y again. So it's sort of a loop-like structure. With this, I think it's now finally time to formalize what you've seen before, because in fact, if you look at it, we have done all of the three things that we wanted to do. Look at this. We wanted to store the frequencies in place, which we did by putting that minus sign. We wanted to exploit these indices, which we did by doing x minus 1 over here. And we wanted to communicate between these guys, and which we did by these pink lines over here, which went on a common juncture and stored their information in this Y. And in this way, we've completed all of our requirements. Let's formalize this guy. Okay, so first thing we want to do is we want to iterate over all the elements. And we'll ask if the current element we're looking at, the x value, which is the nums of I, if the nums of the absolute of x minus 1, basically x minus 1, is less than 0, if we are looking at minus y sort of value, it means that it has already been visited. What it also means is that once it has been visited before, and now we are also currently visiting it. So this is the second time we're looking at it. And this way we can send the answer.append x. We can add x to the list of answers. If on the other hand you're visiting it for the first time, then just set it to negative, and that's fine. If you realize this much, then we can directly jump onto the code. There's also one small thing that I'm trying to do, which is the absolute of x. And if you can figure it out why I'm doing absolute of x, let me know in the comment section down below. Let's get started with the code. Now, usually I show how to code this up with you and from scratch, but it's nothing more than just translation of the logic we have seen before. First, we'll extract out the n, which is the length of nums, and we'll iterate over all of them. I have seen other write-ups which iterate over the list and like they're modifying it in place, which is not a good idea generally. So I've just done it in the form of indices. And so we'll iterate in the range of n. For each of these guys, I'm going to extract out the value x. And I'm going to say if nums of absolute of x minus 1 is less than 0, if the value is sort of minus y in structure, we have seen this value before, I'm going to append absolute of x over here. And if not, if we have seen already, if we have not seen this value before, we'll just make it minus 1 times what it already was. And this answer.append contains all of these values, so we can just return that at the end. Let me quickly show you that this works. And voila, we are good to go. Anyways, this is it for the problem, find all duplicates in an array. I like this problem a lot because it's one of those which you have to know the answer beforehand to know what's going on, and you have to have seen this kind of problem before to know how to do it. But once you look at this particular solution, you should be able to solve any problem that requires you to do this in place kind of operation. I think what really gives it away is this range of 1 to n over here. If you can realize this and catch on to it, the rest of the solution becomes a lot easier. Anyways, yeah, I think this is it. And if you like this video, give it a thumbs up. It helps me a lot and the YouTube algorithm. And if you want more of it, subscribe. As always, thanks for watching.